Fellow algebra students, so welcome to Chapter 9, Section 4, Factoring to Solve Quadratic Equations. In this section, we will learn to solve quadratic equations by factoring. So before this section, we learned how to solve quadratic equations by graphing and by finding square roots. This is just another method to do that, and in my opinion, if it's set up properly, it's usually one of the easier methods. So in order to help us solve by factoring, we're going to learn first to solve using the zero product property. And here's what the zero product property says. It says that if we take a look at the example here, if we have two things that are multiplied by each other, like these two binomials, and it equals 0, well then one of these must be 0. Um, and it could be either or. This first binomial could be 0, 0 times whatever value the other one would have, or it could be the second one um, being 0, or they could both be 0. So we're going to use that property to actually solve for x and get an answer that way. So a couple of examples here. Here's how we're using the zero product property. In example A here, by the way, if the problems are set up like this is the easiest way to solve for x in my opinion. So we have two binomials here. Here's what the zero product property says. It says that we must assume that at least one or both of these equals 0. So the way we do this is we set one up as the first binomial equaling 0. Show my little arrow from that binomial. And we must show that the other binomial could equal 0 as well. X minus 6 equals 0. So what I've done so far here, I've taken each binomial, separated it from the two, and set it equal to 0. From here, I'm going to use simple algebra to solve. So on the left here, I have x plus 3 equals 0 from this first binomial. To get x by itself, I'm going to subtract 3. And I'll be left with x equals negative 3. And that's one of our answers to this quadratic equation. For the second one here, x minus 6 equals 0. Again, I'm going to solve for x. So add 6 to both sides. So x will equal positive 6. And we're done. For this problem, we had two different answers, x equals negative 3 and x equals 6. We can show our answer just like that, put it in a box around it. Again, with quadratics, we could have one answer, two answers, or no answers. So it's okay if we have two different answers here. For the second problem here, again, I'm going to set each binomial equal to 0. So over here, we'll take the 2y plus 1, set it equal to 0. And on the other side here, let's take y plus 4 and set it equal to 0. We'll solve separately, and we'll see if we have two answers. So again, solving equations, I want to subtract one here first. So this will be 2y equals 1. Dividing by 2 on both sides, I'm going to end up with y equals 1/2. Fractions are fine for answers. And on the other binomial here, y plus 4, let's subtract 4 from both sides. And on this side, y will equal negative 4. So my answers for this example are 1/2 and negative 4. Final example here, again, we're going to take each binomial, put it by itself, and set it equal to 0. So 2x plus 3 equals 0. And on this side, we will have x minus 4 equals 0. So for the first binomial here, I'm going to subtract 3. I will have 2x equals negative 3. Divide by 2 to finish it off. And we will have x equals negative 3 over 2. Finish off that 2 a little bit better. For our second answer here, looks like I'm going to add 4 to both sides. Jumping ahead just a little bit. And x will equal 4. So my two answers here on this example are negative 3 over 2 and positive 4. Again, I think this way is probably one of the easiest ways. As you saw, there was not a lot of work to do. For us to use the zero product property, though, we do have to have two binomials equal to 0. So that's the only catch there. But when we do have two binomials equal to 0, it's very easy to quickly come up with a solution for x. Here's your first U-try problem. Complete it both in your notes and in the Google form below. All right, and as I mentioned, if quadratic equations are set up as two binomials, it's really easy to use the zero product property. The problem is a lot of problems aren't set up like that to begin with. Most of the time we'll have a polynomial. The thing is, we can use factoring, like what we learned in last chapter, to separate that polynomial into two binomials and then use the zero product property. So this is kind of a checklist on how to use the factoring method to solve quadratics. But in order to use that zero product property, we have to factor. We have to get to two binomials. For this to happen, we must have a quadratic equation that is equal to zero. And what that means is one side of the equation has to be zero. If it's not, then we have to use algebra to make it equal to zero. And we'll have an example problem where you'll get to see that. From there, we factor the polynomial like we did last chapter in hopes of getting those two binomials, and then at the end, we can use that zero product property to solve for x. So we have two problems here for examples. And the directions say solve by factoring. So what I'm going to do, first I'm going to check and make sure this equation is set equal to 0. And as I look here, I have x squared plus 8x plus 15 equals 0. So we're ready to go. We can factor this. So I'm looking here. If you remember factoring, we wanted to find factors of a times c. So I'm looking at factors of ac. I'll just scribble that out. So 1 times 15 is 15, and they have to add to, looks like a positive 8. So if I'm picking factors here, I'm going to pick, looks like a positive 5 and a positive 3, and those do add up to 8, so that is the combination. So since the a is 1 here, makes this pretty easy to factor. We're going to have x plus 5 and x plus 3 as our two binomials. And it equals 0. And it's important that it equals 0 because now we can use that zero product property that we just learned in the previous examples. So I'm going to set each of these binomials equal to 0. So we're going to have x plus 5 equals 0, and we're going to have x plus 3 equals 0. Solve for x on both binomials. We're going to have x equals negative 5 for this particular one. And it looks like we're going to have an answer of x equals negative 3 for this particular one. So two answers, negative 5 and negative 3. That solves the quadratic equation. Example B, here's a special one. This is how these problems get a little more difficult. Notice this equation is not equal to 0. So we have to do a little bit of work up front. Here's how we do that. Let's get rid of this negative 49 to make this side 0. To do that, I do the opposite of what's happening here. We have a negative 49. Let's add 49 to both sides. What that's going to do, that's going to make this side 0. And if you notice right here, I only had 2 terms. I'm now going to have 3 terms, that polynomial that I can factor down into 2 binomials. So adding 49 to both sides, we will have x squared plus 14x plus 49, and I want to write it out like this because I'm now going to factor, equals, and on the right side, most important part, 0. So factoring here, factors of AC, looks like we're going to have factors that multiply to 1 times 49 is 49, but also add up to 14. Not too hard of a problem here because it looks like a positive 7 and a positive 7 multiplied to 49. And when we add them together, we get that 14. So that's our combination. So after factoring it, that trinomial becomes 2 polynomials, x plus 7 and x plus 7 equals 0. Notice that these two binomials are the same. Keep that in mind for at the end of the problem when we come up with an answer. But if I set them both equal to 0, we'll have x plus 7 equals 0 and x plus 7 equals 0. On the first one, subtract 7, we get x equals negative 7. So that's one of our answers. And on the second one, we're going to subtract 7 as well, and we'll get x equals negative 7 as well. Wow. This problem has one answer, just negative 7. And again, like we said, sometimes they can have 2 answers, 1 answer, or no answers. This is a problem that would have 1 answer. And the way we can tell that a little bit earlier in the problem is we had x plus 7 twice. And that's perfectly fine. For our answer here, we would just say the one and only answer is x equals -7. Here's your last you try problem. Complete it both in your notes and in the Google form below. Have a good day.